Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenter. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Excuse me, which brings us to today's session. This session will run approximately an hour to an hour and a half with questions throughout, and I'll now turn it over to the speaker for introductions.
Hey, hello there. Good morning, good evening, good afternoon. If you're watching live or watching the recording of this session later, great to have you here. I'm very excited to go over the content for the session today, which goes around machine learning. So I'm very excited about this topic. Couple words on the way of introductions. My name is Armando Lacerda. I am a data engineer and a data architect. I work a lot with data ingestion and work with data lakes and preparing data for business intelligence and also supporting machine learning teams to do data science, to train machine learning models. And I actually train new teams to work on these technologies as well. I'm also a Microsoft certified trainer. This little red square here, it's an icon that I believe you cannot see, which is about the Microsoft certified trainer certification that I hold. I've been a certified trainer for over 26 years, and I love presenting technical content, in particular Microsoft content, in a classroom, and see people growing up on their skills. I hold many Microsoft certifications, been collecting certifications over the years. In order to train a class, you need to get a certification for that class. And I've been learning, getting myself up to date on Microsoft certification throughout the years because I try to get certified on the technology that align to my career path. I'm also a Microsoft MVP. That's not a certification. MVP is an award that Microsoft gives to people like you and me. When we go out and do what I'm doing now, we like to share what we learn and what we know about the technology with other people on a public environment like this or other blogs, answering questions on forums. If you get noticed, the Microsoft team are doing a great job spreading your knowledge around on tech. Usually used to be just Microsoft Tech, but now Microsoft has adopted a bunch of open source technology as well. So when you get noticed and when you're sharing your skills, Microsoft may award you an MVP award, which is super cool. It's one of the things that I cherish a lot. If you want to keep the conversation going after this session, you can connect with me through LinkedIn. LinkedIn is my preferred social network for keeping the conversation going. If you have questions there, specifically on this session, if you like to go over into the larger community, there are many LinkedIn groups we can connect. I'm a member of a few of them. You can connect with me there. We can get connected there. Stack Overflow is also a great place to go, and sometimes some of the GitHub repos that are out there on this topic. I don't tweet much. My Twitter handle is usually an echo of what happens on LinkedIn. And Facebook's more for personal stuff. You're not going to find much technical content there. But I'm there too. And the agenda for today is a pretty brief, short one. Actually, if I go back here, our session is about logistic regression. And logistic regression is one type of statistical model we can use in machine learning. And today's session is about a particular workshop that's available for you in GitHub. And Microsoft wants to show you how you can experience and experiment this workshop on your own later after this session. So the goal for this session is twofold. And if you have been following along these sessions we've been presenting lately, you know that what we do here, what we've been doing here is one, present you the actual skill content. In this case, today is going to be logistic regression. The other one is to show you that there are a lot of Microsoft resources made available for free for you to study on your own pace, right? At your own pace. When you have time, you go to your computer and do your things. This content is usually shared through the Microsoft Learn website, microsoft.com/learn. And you're going to find a ton of learning paths there. You're going to, pretty much in all Microsoft techs out there, especially the cloud ones, you're going to find tons of content there made available for free for you to go and study from there. Some of the content there will provide you a sandbox where you can go and do your exercises on isolated environment, kind of a isolated, protected environment where you cannot destroy anything. And some of those learning paths there, they will require you to run on your own computer. Today's workshop is this kind of experience. You're gonna need to have some stuff installed on your own computer. If you're running Mac, if you're running Windows, if you're running Ubuntu or any other Linux flavor, you're gonna need to have something installed on your computer. And I'm gonna guide you. I'm gonna show you what you're gonna need in order to do those exercises there, right? But the actual content that's very particular to this session, to this content here, Microsoft has been migrating a lot of their open source workshops into the Microsoft Learn platform. But this particular content here is not there yet. So if you go into, and let me get my browser here just quick. I have it here handy. 1 second. There it is. Mouse. There we go. Let's get this guy here just quick. And I make myself here smaller here in the corner so we can follow along. So if you go Microsoft.com/learn, you will find all the learning paths being introduced. We have seen together in previous sessions, and we've been introduced to with me and other presenters. And you're gonna find machine learning here. If you go ahead and 1 second, let me click. There we go. If you go ahead here and search for machine learning, you will find machine learning. There we go. You will find a bunch of learning paths in here for, come on, go on, for this particular topic. See, create machine learning models, understanding data science, and there are a bunch of learning paths here you can go ahead and follow. But there are also some old style workshops that Microsoft has not moved into this platform yet. And if you spend some time searching through GitHub, that's not as friendly as this environment here, you'll find a bunch of workshops there as well. In particular, the one we'll be using in this session today is in this link here. Let me get the link once again. There it is. Copy. And paste. There you go. So, and Irina, who just introduced us to this session just a few minutes ago, will have that link on the comments there for you guys. So you can also click and do, that she's about to post it there. So you can click in there and do it on your own pace, right? Don't try to do it with me here. You may go faster than I do if you just click on the cells and execute it, or it can go slower if you start looking into the things. So for this moment, for the next hour or so, we invite you just to follow along here with me, and I'm going to introduce you how to do these exercises, introduce to you how you can do these exercises on your own. There are some pitfalls on the way, but the bottom line is today's sessions is based on this particular workshop published by Microsoft for the reactors, right? All the reactors around the world, and they have this workshop there for people to try it out. And today will be my privilege to show you how you can leverage this and start learning a little bit about how to do machine learning and how to use regression algorithms on a particular data set, on a small data set, right? So that is that. Let me go back here to my slide deck just to wrap up these introductions. So bottom line is we're gonna do this logistic regression on that from that workshop in GitHub. And our agenda is super simple, right? I have one slide about a brief intro on machine learning. And then will be the workshop. Then we're gonna get into the workshop and see how the workshop works. Okay, so let's go for it. So when I was preparing the slide deck for this session, I was like, I don't want to really go deep into this because we can get into some rabbit holes that will take forever. We'll suck up all our time together. And I want us to focus on the hands-on. I'm sorry, I'm getting a little thing on my throat. I got something to drink here just great. Yeah, you can do logistic regression Power BI too. So I decided to go just for a picture because, as we know, most people agree that a picture can represent more than 1,000 words. And I decided to go for a picture. And I went lazy. I said, you know what? I'm not going to go try to draw the picture myself, try to draw something in PowerPoint. I'm going to find something out there. And Larissa just posted a link there just after the GitHub link is already there in the chat window about this particular picture here that I found really cool. This guy, Samuel D, you're going to find it on the link in there. I want to give him credit for publishing this one here. This is a great illustration about the most basic approach to the most common tasks we do when you do machine learning. So what is machine learning? Artificial intelligence, it's a broader term that people discuss how to implement, try to discuss and design how to implement the human brain's pattern of thinking, of problem solving, and implement that pattern into a computer algorithm. So the idea is to make the computer imitate the human brain. It's a pretty auspicious goal, right? And there are a lot of resources going out there. There's a lot of ethical debate about that. We don't need to get much into that. For us, when we're talking about the current state of artificial intelligence and focusing specifically on Microsoft offerings up in the cloud and for data science implementation, we can see artificial intelligence into two branches, right? Two particular, not these branches here on the slide deck, but two particular branches. One branch is the one that when you consume already trained models to apply machine learning to your particular context, to your particular use case, to your particular application need. You're going to develop an application, and then you want to have some machine learning embedded in your application. For instance, you're like my daughter. You're doing dog sitting, and you want to do dog recognition, image recognition of the dogs that are coming in. So we're going to develop an app and click on that dog there, and you want to train the model to recognize who is the owner of the dog, all the information about the dog. So when you see the dog, you see all the information you need about the dog. Well, there is a model already available for you, and in many cloud providers, Azure is one of them, where you can do that. In Azure in particular, that's called cognitive service, and there is a portion in cognitive service called the vision cognitive service, the vision service, which we'll have a session on that one later down the road. So there is one you can use. You don't have to program anything. You don't have to train much. You can train on particular images if you have specifics on that one, but in generical terms, you can use out of the box with minimal time to production, which is great. On the other hand, and that's the one I want you to focus on the other hand, when you need to start a machine learning model from scratch, because there is no one available for you for your specific use case up in the market, right? You need to train one for your particular case. Then you do what Microsoft calls machine learning itself. So you have cognitive service with prepackaged, pre-trained models, and you have machine learning when you have the statistical models you would use to do machine learning, but you have to train the models yourself. It's on you. And in that particular case is where this session fits in. When you need to get a machine learning model, which is for the most part is a statistical model. There are some that are not, but for the most part, they are statistical models. When you need to get those models and train those models on a particular data set of yours for your particular use case in order to create a calculation that's tailored to predict, depending on the case, right, to predict the behavior or the result of a particular combination of data on your production, streaming, batch data set, whatever it is. So that is machine learning. That's where we are here, right? This is machine learning. So machine learning is when we are creating something, we are training a model from scratch. Now, this thing about the model, what is the model? We're talking about model. What's the model? It's like a beauty model or something like that? Well, could be. But in this particular case, the model we're talking about are specifically statistical models that will, the idea is when they look at some data combination, they can calculate a possible result. So your data combination, your particular description of a state is a collection of features, what would be columns in the table in a database, for instance. So it's a collection of features. And what you're trying to predict is your label, is the information you're trying to predict, right? If I see, something that looks like if I see an animal that has 4 legs and walks on 4 legs and tails wing the tails and got the ears and shapes like this, so that could be a dog, could be a cat, depending on the shape, and the size of the ears and the size of the tail and so on. You get more specific based on the attributes you see. You can come to the conclusion that's like a dog or a cat or something else. Here's the same thing, right? We get the machine. We're gonna come to choose a particular model and a particular method right here, right? A particular method of which model we want to use. It's important to understand that when you get to these methods, they all have their application, right? The particular case when they're really applicable and not applicable to other cases. When we do supervised learning, when we are doing machine learning and we have data, we can look into the past and see, look into the past. When I get this particular combination, I get this result for the most part. When I get this particular combination, I get this result for the most part. When I have historical data that I can train, kind of calculate what would be the possible answer given a particular combination, that's usually a supervised training approach, which means we're going to give data for the algorithm to train on. And when we show new data, it will use the observed results in the past and give a particular result for that instance, the label, right? The prediction, the label for that instance. On that one, we find our session today, right? The regression one. There is another one that can also be used, which is the classification. So usually you have these 2 types of statistical models. There we go, the models. The statistical models you can have. So like for regression, an example could be, divide the ties by length. And for classification, you can divide the socks by color. These are 2 cases that I found on this page that Samuel published. I found really cool examples, very simple to understand. And the idea here is for marketing forecast on the regression and for identity fraud detection, for instance, on the classification. When you have ranges And when we have yes or no kind of type of answers you're looking for, that will be the regression case. Just for the sake of completeness, on the other side in here, on the unsupervised learning, what we're seeing here is the search. We're going to use statistical models, of course, for the search of common elements on data that we have never seen before. And for that, we can do either clustering or association, identify sequences or divided by similarity. In either case, we don't have the process of training. We have the process of adaptation. As the data comes in and we look into the patterns of the data, and there are many videos out there, there are many books out there, other sessions in the React about that, where you can see the details about that. As the data comes in, you see the commonalities of the information coming into the system, and you can start making distinctions based on the seeing common elements. A very common example of that one, it was the actual very first time that I tried machine learning, and it was a clustering element, a clustering implementation exercise in my case. Yours is going to be a regression, right? In my case, it was a clustering one. My very first one was for voice detection, and not voice recognition. It's like, not, you're hearing this is Armando. This is not clustering. But it was a case when you have a microphone on a table and you have two people talking, and you have the machine learning model needs to separate both person and the background, remove the background, and say this is person A and this is person B, without having actual identities, just identifying the distinct sources of the talk based on voice patterns, without any training, just by seeing the common, like the pitch, the pitch of the voice and the cadency, and remove the background noises that has nothing to do with either pattern of each one. So that's done by clustering. It was my very first one. I thought, wow, that's super cool. Perhaps some other day we can do this one here together. But for today, we're going to do this, right? The regression. Now, in order to do machine learning, either way you're going to do, and in our case again, here again, regression, you need a compute environment. You need to have an environment where you can run your statistical model, because your statistical model is calculation, and calculation means you need compute. You need a computer, CPU, you need memory. More likely, you're going to need storage to save your data, and you're going to read the data from there, write the data to there. So more likely, you're going to need storage, but you need compute. This session, today's session, is not about Azure. We could do this one here in Azure, and perhaps if you have time later, I can show you, give you some tips about how to go to Azure for free to do these things. But for the actual workshop that is made available for you, you're going to use your own computer for that. Like I said, in this particular workshop, they want you to use your computer. You're not going to do anything harmful in your computer, but you will need to install some elements on your computer. So let me guide you to that. Let's see where the assets for our workshop are and how we can prepare our environment and start working on the workshop itself, all right? So fasten your seat belts. We're going to go for that one. Let me see if there are any questions in here. I see only arena entries with the links in there. I don't think there are any questions yet. Arena, if any question pops up, please go ahead and put it there for us. All right, so let me go ahead and switch to my virtual machine. I have this virtual machine here up in Office 365. This one is actually a Windows 10, I think. It's still running Windows 10 virtual machine on the Office offering, Windows as a service, which is super cool. And in here, I have installed Visual Studio Code. So I'm going to go back to Visual Studio Code in a second. Let's go ahead and look into the actual workshop. So let me open here the browser. And this is the link for our workshop. Let's see. Oh, right here. I left it open right there. Perfect. Let me close these other tabs in here and make sure we are on the one that you're gonna land, right? When you click on that link that I'm going to put it there on the chat window. So in here they have a welcome page there with some instructions. This is the agenda we're gonna go over, and our this link here is a broken link. Don't click on this one. Our actual content is in this link here. I'm gonna press Control click just to open it in another tab in my Edge browser. And in here we have our Jupyter notebook with the Python scripts to run, actually both the content, the actual learning content, and the Python scripts together for us to work on this workshop. I think this one here, this MD file, is just some introductions on the activities. These links here are also broken. They don't work from there. And this is the structure of the CSV file we'll be reading, and all the features, right? The elements that are there in the learning data, right? In the training data that we're gonna be working with. So let's go ahead and get this file to our computer so we can work with this file. Now, this file here is on a repository full of other workshops. So if you want to download the entire workshop library into your computer, you're welcome to do it. But because we're focused on just this workshop, I'm going to show you another way of doing it. I'm going to go to the script file, the Jupyter notebook file. And here, because I'm going to save this file to my local computer, I'm going to highlight the file name in here and copy it. And I'm going to ask GitHub to show me the actual file, the raw data in this file, not the formatted one, because it's a Jupyter notebook. GitHub understands the Jupyter notebook and formats on the screen for me. I want to have the raw file because I want to open this raw file on my local computer, and you're going to do the same, right? And in Visual Studio Code. So this is my raw file. I'm going to hit Control S to save this file on my local computer. I'm going to change the extension here to any extension and change the file name to the one I copied from the browser. And because I'm going to save this locally, I'm going to create a folder for this guy. I have a folder here that I like to work. I like to put these files from the internet and these workshops to work on, called Lab. I'm going to create a new folder here for regression. So just create a new folder in here, empty folder, and I'm going to save it. It's kind of small now, as I know that the screen is kind of small in there. I'm going to get it bigger when you get in Visual Studio Code, just because there is no way to get this thing too larger than that. So a little zooming here. Again, I just created a folder someplace on my hard drive. I don't want to keep it in the downloads folder because I have a bunch of other files there. And I think it's a good idea to have a particular folder just for our workshop, right? And I'm going to save our notebook in there. So I'm going to save it there. Notebook saved. And now I have my notebook ready for me. I can open it in Visual Studio Code. Now, what about Visual Studio Code? Because we're going to do machine learning by coding, we could do machine learning by visual elements if we were in Azure and using Azure Machine Learning or some other service that are out there. But for the most part, machine learning is done by code or coding. And depending on which school you come from and which group you belong to, you're going to use some programming language for that. A very common one, one of the most popular one for this is Python. So you can use any code editor to do your Python scripts, right? To write your Python code. Because you're in a Microsoft workshop, I'm going to introduce you to a way to do that using a Microsoft source code editor called Visual Studio Code. It's more than a source code editor. It integrates with a bunch of other things, as you're going to see. But I think one of the benefits of using Visual Studio Code is it's multi-platform. You can have Visual Studio Code working on Windows, on a Mac, on a Linux. And the way to install it is pretty much the same way in any computer. You go there and do a quick search on Visual Studio Code download. As you can see, I have done this search today already. And if you click here on download Visual Studio Code, you have the options to install Visual Studio on any platform, right? I have it already installed in here. Don't have to do this. In case you don't have it, now you know where to go to do that installation. Once you install Visual Studio Code, let me pop it up here, and let me get smaller here again, so this letter gets bigger. Let's go there, Visual Studio Code. Once code is already running. Okay, sorry. I didn't notice it. Actually, it's not. Let me double check in here. Maybe something hanging on my machine. It says it's here. Visual Studio Code is running. Okay, let's kill this guy. Must be hanging somewhere. All right, let's try this over. Visual Studio Code, there it is. And again, in case you just installed it, there will be other things you have to install Visual Studio Code for the machine learning element. In my virtual machine there, if I don't ask to run as an administrator, it will fail installing some packages. So I'm going to do that. In your case, you may or may not need to do this. So I'm going to do this guy, and he's going to ask me, are you sure? Yes, I'm sure. I know what I'm doing. So here's my Visual Studio. And if you can recall, I saved my file on a folder, right, on my hard drive, on my local C hard drive. Ooh, something is going on here. Let me double check what's going on there. Full screen. That's my remote connection to my environment, and it seems to be failing somehow. All right, let's do this. Let's disconnect from it, and let's reconnect again, see if it comes back better. Let's try to connect here on the other monitor. Bear with me for a second. Let me show you here the screen. So it's trying to connect there. And all right, it's back. Perfect. Now we're talking. There's this myth among the trainers and presenters when you're doing live demonstration. They say you have to sacrifice to the demo gods. If the demo gods are mad at you, all your live demos are gonna bump. Are gonna bomb. And I'm like, oh, I think you did not sacrifice enough early today. In any case, let's go ahead and open that file. I just saved in here. And that file, like I showed you before, is in lab regression, right? I create a folder here for this workshop, and I named that folder regression. Here is my notebook file, and I'm gonna open it here. Yeah, so when I open this file, Windows 10, they have this particular security feature that's like, when you download something from the internet and it's like code that can be executed that could be harmful to your computer. So it's gonna ask you, are you sure you're gonna do this? Do you trust the source of this code? In my case here, I do. So you have to evaluate on your own, right? In my case here, there are no problems. Open it without restriction. So here we are. This is the content for the workshop. You're not going to have this Visual Studio Code pop-up window here because I have something installed on this computer trying to connect to my Azure account, and I'm not signing in there, so it's complaining with me. So don't mind these two messages in here. You're not going to get those. And here we are, right? This is our environment where we're going to run. This is a Jupyter notebook. And in order for you to open this Jupyter notebook, before you try to open this file, you are to tell Visual Studio Code that you need an extension here on this side button here. Let me see. Yeah, on this side button here, there are multiple palettes you can use in here. When you install Visual Studio Code, it usually has only these 4 or 5 first in here. All of these other ones here are mine that I have installed because I work with Azure day in and day out. I need to do stuff in Azure, in Kubernetes services, and some other stuff. Machine learning right here too. But in this case here, you're gonna go here into the extensions and tell Visual Studio Code that you need support for the Jupyter notebook, right? You're gonna type the name of the tag you're looking extension for. In this case, Jupyter is spelled with a Y. Make sure you spell it with a Y. I'm from Brazil, and in Brazil, Jupyter is spelled with an I, not a Y. But in this case, here is with a Y. So make sure you spell it right. And this is the extension that I already have it installed on my computer from Microsoft to support Jupyter notebooks in Visual Studio Code. Here's the thing. Is this required to run machine learning code and to train models? The answer is no. It is not required to do any of this. I can do my training, the training of my models without having Jupyter Notebook, just running straight plain text files, and I can get the job done. Now, out there in the machine learning environment, people use Jupyter Notebooks all the time as a tool, as something to support your work, to help you out, to make things easier to run and to test and try again if something fails, so don't have to run a bunch of code again. So this is kind of a helper for you that's not really required. It has nothing to do with machine learning per se, but it does help our process a lot. So you want to get acquainted to this one. The workshop will use it. The workshop instructions are based on Jupyter Notebooks. You need to install that extension there if you want to do this workshop later. But for the overall process of machine learning, it's not really required. But to be honest, I never worked in a machine learning project where people are not using this. So it's kind of mandatory in a way. So getting back in here, these Jupyter notebooks, they are based on what people call, what actually they call cell, right? It's called a piece of information in there that can be either code or something else. It can be comments, it can be just documentation. In this case here, this particular cell is what they call a Markdown cell. It's a comment, it's just documentation that's written on a language called Markdown. Markdown is a derivation of HTML. It's not really HTML, it does have some tags. Almost all Microsoft documentation is written in Markdown, some variation of Markdown up there in the web. And the idea here is just to have the comments. So in this case here, we get this first cell here. And see, if I browse over the limit of the cell, I see these buttons where I can add more cells of a particular kind. And the idea here, when you do this on your own, is go ahead and read through these things here. I'm not going to read it here for you. Of course, you don't need that. You can read better than I can read it for you. But the idea here is for you to read. This is the actual content for you to learn from. Like we have seen in the GitHub page, this is our training data, right? The structure of the data frame we'll be using to train our model. And there are a bunch of information in here. They're going to discuss this throughout the workbook. And they're going to also explain some of the decisions they're going to make based on this training data they have acquired. Microsoft is really strong. Here's a side note, right? It's written there on the notebook, but it's kind of a side note in here. Microsoft is super strong on pushing the envelope of ethical machine learning, right? When you remember, the whole idea of machine learning is to mimic how the human brain makes decisions. So we can have decision making at scale in a computer environment like the cloud. So instead of having one guy try to predict where the hurricane is going to go by, we can have 1,000 guys trying to make these calculations to see where the hurricane may go by, right? Because they use those weather forecasting, they use machine learning to try to make those predictions. All pretty much based on the same, elements we have discussed in here. So that's the idea, is to have human decisions at scale up in the cloud. Now, if we have bad decision-making patterns, we may be hurting people, because this decision-making based on people's interaction with some business we are automating here, right? So it's very, very important. I'm going to close this sidebar here. It's very, very important for you to understand that when you work with data models and you are training data models based on training data sets, data frames, you have to make sure that you paid attention to any kind of bias that could be in there, or some sort of information that could create a distortion or harm minorities and this kind of things. So be careful about that, right? I'm not going to go back to this subject. I don't want to get political or anything like that, but be careful about that. In this particular workshop here, they will touch on that point. When you look here into the data frame, there are two things here in the data frame. They're like, yeah, we're going to revisit this. There is a gender. The subject of this workshop is like, should I approve a loan application? I think it's to buy a house. Should I approve a loan application to buy a house? And for the sake of this example, they look into these two data points in here, these two features in this data frame. This is one, gender, and the other one right below it, right under it, married. And as an example of features that, based on ethical machine learning, responsible machine learning, based on those principles, you should we may want to remove these two factors, because, in order to be ethical, I don't want to base the loan application approval process in either gender or the marital status. Just a decision that the company decide to. They have the data, but we're gonna consciously, we're gonna exclude this data from the decision-making process for those reasons that I just explained. So this is what the workshop, one of the exercises the workshop will implement. So here's the problem. The problem is to do the loan application. There is a fictitious company name down here. Oops. There we go. Contoso Data, right? It's a fictitious company application down here. You don't need to change any of this. This is just for your reference. Ethical practices, just mentioned those. Remove gender and married fields, I already just mentioned those. And here's the process that workshop will guide you through. So you're going to understand the domain, make a plan, exploring the data, prepping the data. And these are two tasks that people usually do. Let me take the mouse out of scope there. Move it away. Yeah, get it like this. So the actual training, the regression training, is done down here on the training the model. This process here, from 1 to 5, from 2 to 4, this process here, it could actually be classified as data science. This 2, 3, and 4 steps here, they can be actually classified as data science, because we're going to be exploring, going to load the data and be exploring the data. Our data here is super small, but when you move into a cloud-backed platform where you can handle, tons and tons of data and do this processing there, you have way better models, way better trained models than what we're going to do here. Here's the process exactly the same, but the scalability in the cloud really gets this thing here on asteroids. All right, so this is the process we're going to be doing, and let's start a few of this. So here goes with the plan. And then there is another element to your environment that you're going to need in order to get this working. In here, they're talking about importing libraries and data. Importing two things, libraries and data. Now, what are these libraries, in case you are new to this guy here, the libraries? Actually, let me get out of this and do the zooming this better. Oops. There we go. So what is this thing here about the libraries? What is this? So remember, our machine learning models, they are statistical models. And those statistical models, I mean, for the most part, right? There are some machine learning tasks that are not really based on statistical models, but they have other patterns. But for the most part, all these patterns in the statistical models, they have already been coded. There are some developers that mingle together with some statisticians, and they put this, in compute code around those statistical models. So the only thing you're going to do is give that model data. So the code that has been already developed by other people, they are packaged, they are wrapped up, right? They're made available out there on the internet in the forms of libraries. And depending on the programming environment you are working on, there will be a particular way to download these libraries, to get these libraries available for you. In this workshop, we'll be using Visual Studio Code to see our code like we've been doing right now. But we also need a programming language. And the programming language they have opted for this particular one, like I said, that's one that is very common out there. It's super popular. It's called Python. So if you don't have Python already installed on your computer, once again, you're going to resort to your browser. Let me get my browser here. See the icons behind my name there on your screen. Here's my browser again. And now what I'm going to look for is for the Python download. Here we go. So Python is a programming language. It's an open source environment for programming language that you can download and install on your computer in any of these platforms we discussed, right? Windows, Mac, Linux, you can go and download. Actually, if you are running on Windows, you can even use the Microsoft Store, Microsoft Windows Store, to download Python from here. You can come in here and look for Python. I see games there, but games and movies are also cool. But I can look for Python here and see I'm gonna find the Python installer also from here if you're running from Windows. Regardless how you want to do it, right? You need to install Python on your computer. Let me close that. And so you're gonna download it. Yeah, I have my one already downloaded. You're gonna download and open the installer there, and you are going to allow it to install. Once it is installed, like we have done for the Jupyter Notebook, you also gonna do an extension for Python. So Visual Studio Code knows that you have Python on your computer right here. See, it's already installed in my case. This guy here, Python for Microsoft, is already installed in my computer. So the integration is already there. If you don't do this and you try to run a Python code, Visual Studio Code will tell you, hey, you need an extension. You would like me to install? And you can go ahead and install it from the prompts that will pop up for you. When you download these extensions, just one piece of advice here for you. When you download these extensions, make sure you're aware of the source of that extension, because Visual Studio Code is open for the community. If I want to, I can write an extension and publish on the market and people can download it. And I'm not a bad actor, so I'm not going to do anything that harms people. Usually content here is curated. So, I never heard about someone being, hurt because downloaded something from the extension here. But make sure you understand that like this extension is authored by Microsoft. This extension here is not authored by Microsoft. It's by another guy who is pretty reputable. People know him. And this one too, and so far, so on. The whole thing about these extensions is this is code that someone has developed, may or may not have bug. Usually they do, they all do. And how stable it is and how much more problems it's going to bring to your environment, it really depends on the extension. So, to be on the safe side, try to use this one for Microsoft. There are some other ones that, for other techs out there that are better than Microsoft ones. It's just a matter of choice for you. Bottom line is, you need to install Visual Studio. You need to install Python, a particular version of Python. 3.10 is the latest one. I'm using 3.9 on my environment. And you have to install the Python extension integration in Visual Studio Code. And that makes it almost done. Because when you have these three guys, you have the environment to run your code. But as it says in here, your Python code depends not just on these three guys, but also in some machine learning libraries that are available out there for you to bring down. Because when you install Python, Python doesn't bring all the libraries that are available out there. It just brings Python. And if you need to use machine learning, and in our case here, the regression model, you need to get those libraries also down on your computer. And the way to do that, usually when you open it like this, it's just let me collapse here the extensions so you don't see the extensions anymore. It's just your code. And if you press Control and the apostrophe, the key right on top of the tab key on your keyboard, Control and that key, you get the command prompt here. There is another way to get you there. I think it's here. If you click terminal, yeah, you see new terminal, Control apostrophe, Shift apostrophe. Control apostrophe is just the terminal you already have. Now I have two terminals. See here on my right by my side here, this side, I had two terminals now. So we get here the terminal. And here in the terminal, you're going to ask Python, once you have installed Python, to download the libraries you need. Like I need pandas, that's there. Pip install pandas, like this, right? And in case you're wondering, where did you get this from? Armando, did you, was born with that in your head? Definitely not. So what happens in here is when you see a library that you need to use, one of the things you can do is, of course, ask a search engine like Google or Bing. I'm going to use Google here just because we're in a Microsoft session. I'm going to do here and see Python pandas install pip. Because in Python, when you need to install a library, you use pip. This is one of the ways to install that. And then you can get to some place in there that will give you some instruction on how to do that. This is one over here. Let's see what this link says. So, that's what someone asking a question, like we're looking, and here's the answer, and someone vouched for the answer, pip install pandas. Now, there are other libraries there that we need to install too, right? So pandas is one of them, NumPy, and matplotlib, right? We had two other libraries there we want to install. So if I go back there to that, whoops, where's my mouse? Here. If I go back there and look for those guys, it's kind of the same thing, right? If I go back here, Python, NumPy, installing NumPy, and you can see here some of the ways you can install NumPy. This is from numpy.org. There we go. And on using pip, conda is one of the ways. Pip is another way. Pip install NumPy. So if I go back there to Visual Studio Code, I can go ahead and do the same thing. What happens if I don't do this? If I don't install a library that I need, when I run the cell, it will give me an error. Hey, you don't have that library. You have to install that library. And then you have to do this search that I have just done. So let's go ahead and run this. Oh, there is one more thing in here. Look at this. This cell, let me scroll up a little bit, zoom in there. This cell here, it loads not just this 3 libraries, but it also reads a file with data, right? A data frame, a CSV file that will be our data frame. See, they create a variable here in Python called df. It's usually the acronym for data frame. So we are reading this file into our running environment in Python. Now, the thing is, I don't have this file yet. So let's go ahead and find this file, which is in the same GitHub repository. I'm going to highlight this name here because I'm going to save the file with this name. And I'm noticing here that it expects to see this file in a folder called data. So I'm going to download it to that folder called data. Let's go back to GitHub. Where's my mouse? Here's my mouse. Back to GitHub. That should be here. Nope. Here. So let's go back here. This is the original Jupyter notebook. Here's the folder data. And this is the file, load prediction with data. There we go. So I get to this file here. And same technique, I'm going to ask to see the raw file. This is the raw file. And I'm going to press Control S to save this file on my local computer. Oh, fine. This time around, it came with the file name, even better. So it's expected to see this file in a folder called data. So I'm going to create a folder here called data and open the file there. Open the folder and save the file there. So file is saved, perfect. Which means that if I go back here to Visual Studio and I look here into the folder explorer, I can ask to open a particular folder. And that's the regression folder that we are working on. And here is the data folder I just created, and my file should be in there. Oh, come on. Yeah, you can trust. You already asked me that before. So trust the code, source code that is in here. Here's the file you just downloaded, and here's the notebook we are working on. Very good. Let's cancel this. This is the Azure login that I mentioned to you that these guys want to see. And where were we? We're getting ready to do this, right? So this cell here will load the libraries. Remember, I have to have the libraries already installed, and I think I have already installed them. So they're going to load the libraries, and this one here will read that CSV file from the data folder. The file is already there, so when I run this, when I run this, it's like, okay, this is in Python. So where is your Python? You can have multiple Python versions installed on your computer. In my case, I have only one. It's suggesting me, hey, actually I have two. I have a 64-bit and a regular 32-bit. So which one do you want to execute? I don't know. I'm going to go for the suggested one. It's suggesting the 3913. So I go for that one. And it's telling me that I have to install, look at that. I missed something, IP kernel package for this guy. So let's go ahead and install. And here behind me, see on this side, you're seeing it being installed. And it seems it failed. And it failed. I told you before, right? For some reason, my computer requires this guy to be on the under administrative privileges. And it restarted. So it's not running as an administrator. Let me do that again as an administrator. You may or may not face this particular issue when you run on your computer. It depends on the OS and how the OS is configured. So let's try that again. Where is it? There we go. This is the cell that tried to execute and did not work. So let's try to execute it again. And again, to execute these cells, you click on this little play button here on the left side. Just hit the guy there. It's going to ask me to install it again. Hopefully this time around, it will install. And it seems it Nope, it did not install. Funny. One last try before we bail out on this guy. So there is a pip installation in here. Let's do this guy again. See if it works from the command prompt. Down here, my command prompt, clear, and let's get installed from here. Going once, going twice. Meanwhile, let's see if there are any questions in here. I see one from Tosif Reza. Is data cleaning? Oh, there you go. Thank you, Irene. Is data cleaning involved in one of those steps? Not really. For this one here, just removing the features, right? Just removing 2 features in there. Data cleanse is not involved in here, but it's a great question. It is a task that is most of the times done before you train any model. Now, the thing with the data cleansing, and it's a great, thank you for asking that question. It's a great question. The thing with data cleansing is there usually is a shared responsibility in between the data engineer that we got the raw data from whatever sources and putting them in a particular schema that matches a data frame that can be given to machine learning model training. And sometimes it's also based on the data scientist or the machine learning professional that will also needs to do some rebalancing of the columns, right? In terms of converting data into numeric scales and things like that. That could be done by data engineer. Sometimes it's done by the data scientist. So it's a great question. That particular task is not included here in the workshop, but it is a task that happens when you are dealing with data before you train the model. Thank you for the question. All right, so that was the only question that was in there. Okay, so it did work from here. It seems the installation did not bleed. And when something fails on the installation, it gets a red font, red typeface there. And we joke about that, say the computer is bleeding because you got an error message on the screen. In this case here, I don't see any error message. So let's try that cell again. See if it flies this time around. So see the screen is bleeding right here. Let's see if we were able to stop the bleeding. Run. Let's change the kernel because it just installed it. It should not miss it. Aha, was just the kernel. The suggested one, the 32 bits one was not okay. The 64-bit one worked this time around. So there we go. It was just the kernel. And once again, in case you are missing it, what just happened? When you run a Python code from Visual Studio Code, that Python code will be executed by the Python itself. And there are multiple versions of Python that you can install side by side on your computer. In my case here, I have 2 Python implementations. I have 2 Python platforms, a 32-bit and a 64-bit. I had the 64-bit I had the 32-bit selected before. Let me zoom in here for you to see. So this one here, the suggested one was the 32-bit one, and that one was failing for me. So this one here, the 397 for 64-bit is the one that I have selected right now. And this one is the one that worked. So when you try this workshop on your own, you see it down here. Let me zoom in there again. See? 64-bit selected at this moment. So when you run your this workbook on your own computer later, that's one of the things you want to pay attention to. All right, so now I have a data frame loaded into memory. I just loaded my data there. Let's take a look. Where was it? It keeps moving from cell to cell. Okay, this is the cell we just executed, and we load the data, and it took 2.3 seconds to load that data into memory. The data is in memory. Now we can do the next exercise. So in between exercises, usually the last point here in the workshop is like, is it either a question for you or a challenge for you to try out? This particular one is just a question, right? Remember, The read underscore CSV we used over here, read underscore CSV, is a method from the pandas library. You see the over here, right? The pandas library that got a nickname PD in my code. So every time I write PD, I'm using things from the pandas library. So it's give you a reminder in here that this method is from the pandas library that you have executed over here. And there are some variants to it. It kind of points out those variants there. And take this message out of the way to avoid distraction. So let's take a look. Here is our data scientist talking, right? Here is some of the methods you have in the data frame to see how the data you just brought in looks like. So I'm going to hit that play button here for this guy. And the describe is going to read the data frame, supposedly. There we go. It's going to read the data frame. I think I clicked on something here to minimize the code. The code got, okay, describe, now it's there. Yeah, so application income, you see, so these are the features we see in our data frame, and some, statistical elements, some aggregations done in there. Some more information about the data frame. So if I click on that play here again, you see some other elements in there, like loan ID. Loan ID, the data type for loan ID, it's like, I don't know what this is. It's going to call it a generic one, an object one. This down here, line number 6, let's zoom in there. This one here, line number 6, application income, seems to be a number, so it's an integer 64. These data types are something that's important because statistical models, they work with numbers better than they work with objects or strings. So if you can get your data remodeled, or they call it kind of the denormalization process, or when you get strings represented into dictionaries of numbers. So statistical models, they can work better with those numbers instead of working with the strings. So look into the data. The data distribution is always something that we do when you do data science before implementing any machine learning model or train any machine learning model. This one here is that step we mentioned before. They're going to remove from the data frame gender and marital status from the data frame. They're going to remove these two features. So is my mouse there? Yeah, mouse is there. Let's execute this guy. There is a keyboard shortcut for this. If I zoom, it disappeared. Let's try this again. There it is. If I zoom in here, see, to execute the cell, I can just click on the button or press Control Alt Enter. So if I go here and I have my mouse click blinking in there, I can hit Control Alt Enter, and it runs that one for me. Now, gender and marital status are not there anymore. In case if I want to check that out, see line numbers 1 and 2 here were gender and married. If I do this info again, those two columns are not there anymore, right? Those two features are not there anymore. And off you go. There is a bunch of other exercises that go here with you. After removing this one here, let's say, okay, let's save this one here now. Since we just modified it, let's save it to a new file so we don't have to do this remove again if you want to do some tests later. So we can run this guy here. It just saved. See, the file just popped up in here. So it's something you can do. You don't have to do that, but something else you can do. Here's a bunch of other data explorations, and from now on, you're good to go to explore all the tasks and, of course, the regression elements. That's all the way down there. All these box plots in here, they're creating data distribution, so you can see how the data distributes over a particular pattern. This for loan amount, this for loan amount. So most of the loan amounts are around here. Some are around here. They should be in thousands of dollars, and the amount of application for those. So this is all data exploration, right? That you're really doing there. some challenging here for you to see if you can do. They don't provide the answer, so you have to do it. They provide tips, but not the answer. Yeah, some more data exploration going on over here. Let me see. Yep, more data exploration. No changes on the data itself, just data exploration. Yeah, so some data transformations in here to the question that was asked before, right? Here they're filling null values with some calculated information. So like if there is no loan amount on a particular row, you can either remove that row because it's not asking for data, so remove that row, or you can fill up that row with some calculation. In this case here, the mean of the loan amount itself. So it's filling those gaps with info. Some data scientists, they like to keep the amount of rows and adding those, fill up those gaps. Some data scientists, they're like, I really don't need that because there was no request for loan in there because there is no value in there. They're just trying, can I have a loan of any type? So that's not really what the data we're going to work with. So we're going to remove that from your training set. So it's all on you, right? Whatever you want to do. The self-employed column, what is that one here? They're checking loan amount by education and self-employed amount, self-employed. So you see that the not graduated and the graduated, the non-graduated request for less, the graduated request for more. They want to live better, it seems. And some of this distribution over there as well. What else? We're getting close to the point where we'll see some more data transformation here. So see, it's not really data cleansing, right? It is data, not modeling. What's the name for this thing? It's not data modeling, it's data normalization, right? You're normalizing data, trying to remove data that cannot be applied into statistics to some more normal form of the data. And here is the core of it. At this point here is exactly the core of it. So building the predictive model. Once your data frame is in a point where with data without the gaps, with removing noises, data noises and these things. So the actual training of the model goes right here. Here we are using label encoder to transform non-numerical values, and down here we are into the training. And right after the training, we can use that model we just created to run predictions based on an application that just came in and looks into the data that they have seen before and see if that is an application that we can or cannot approve. So you see the actual regression model is, the exercise for the regression model is actually down here. The majority of the workshop is about preparing the data, normalizing the data, get all the data ready for the model to work on. And to learn about the model itself, we have to go into documentation, the pandas in this case for the library. You have to go into the pandas documentation and see what that particular model that was chosen in there, how it works and what's expecting from your data, right? If it can work well with strings, if it's better to normalize and all of that. So the mathematics behind this one and all the mathematical thought process in the statistical thought process is explained in the documentation. And as a data scientist is something you really want to learn, right? Learn from, read it from the documentation and make an educated decision on which model to use. So with that, we are 1 hour and 15 minutes into this. You're ready to run the workshop on your own computer. And I hope you're going to take your time, right? You're going to make time, take your time to experience that. And in case you have any questions later about how to run these things and what the elements, some specific details in there, please feel free to connect with me on the social media. And I'll be happy to try to, answer some questions there for you. All right. In this particular case, again, you have to use an environment of yours where you can install all of these prerequisites in order to run predictive models. In this particular case, the regression one. You can do the same exercise using Azure Machine Learning if you want to. you can upload this notebook in there and run it from there and have it in Azure Machine Learning. With that, I will look into here. I don't think there are any more questions pending. I'll give back to Irina. I hope we have learned something new, and I'll see you again next time.
Thank you, everyone, and thank you to our speaker for joining. If you have any feedback, we'd love to hear what you have to say. I've added a survey link into the chat for this specific event. It's 15883. Thanks, everyone. Until next time. Bye.
Goodbye.